Hello and welcome everyone to another video where me and my teammates we try to make programming, a lot simpler for you. So today in this video we're going to be tackling one very simple question. We're just going to find out if any given number is a power of 2 or not. All right? Now, if we talk about, let's say solutions, there are many, right? And if we talk about the most basic ones, we can have a very naive, a very simple, a very beginner implementation, if I can say. You can have, let's say a number, I can do a loop, I can have while this number not equals to 1, I can check if the remainder of this number divided by 2, if it's 0 or not. I can return, I can then divide this number by 2, and this loop goes on, right? Up until, until this program completely executes, right? There is absolutely no denying the solution is not going to work. But I want to make this a little more fun, yeah? Because we're going to do it CS style, yeah? So, if we talk about the very basics of computer programming, everything we may write in any high level language such as javascript, let it be c++, let it be java or anything, everything ultimately burns down to basic binary, right? So if I want to, let's say, represent anything, it is always going to be represented in formats of 0, 1, 0, 1, 1, 1, 0, 1. Now, this information can be anything, right? It can be a number, it can be binary coded ASCII, it can be anything, right? But let's say if I do write down a certain number, let's say I have 0, 1, 1, 1, 0. Let's have 1 over here as well, right? Again, we're gonna given that we're gonna solving it CS style, we already know that counting in computer science or in computers it begins from 0, it does not begin from 1, right? So if we count from, let's say, the right to the leftmost side, right, we go RTL, right to left, correct? So this is index 0, this is 1, this is 2, 3, 4, 5, right? So if you know your computers, right, this index in binary, right, this particular index in binary is always 2 to the power of this index, right? So this is 0. As such, this becomes 2 to the power 1. This becomes 2 to the power 2, so on and so forth. This is 2 cubed. This would be 2 to the power 4. This would be 2 to the power 5. And we can go on, right? So ultimately, if I want to calculate what this number is in binary, in decimal, sorry, right? So this would be basically what? This is 16, 8, 32, 16, 8, 4, 2, 1. So this is 32 plus 32, 16, 8, 4, 4 and 2. So this is basically the number 38 written in binary, right? So let's do it once again, right? So given that indexes always run in powers of 2, right? So let's say I have first base, I have, let's say, 32, right? Then I have, let's say, 16. After that, it's going to be 4, then it's going to be, oh, sorry, it's going to be 8, then it's going to be 4, then it's going to be 2, and finally it's going to be 1, right? Now, let's say I want to represent the number 5 in binary. So that would be 4 plus 1, and everything will be 0. If I want to write, let's say, 24, this will be 16 plus 8, and everything else will be 0. Yeah, correct? Now, building on this exact same logic, let's see what happens when I try to represent powers of 2 in their binary formats. Yeah. So ultimately, let's say I want to write 16. 16 is a power of 2. So this would be 16 and everything else will be 0. Yeah. Let's say I want to write 8. 8 is again a power of 2. So that would be 1, 0, 0, 0. If I could write. If I talk about 4, it's going to be 1, 0, 0. 2 is 1, 0, and 1 is just 1. So if you notice a pattern, if you noticed, you'll see that any power of 2, when written in binary, it always starts with a 1 and is always followed by a certain number of zeros. It starts with 1 and it's followed by a number of zeros. It starts with 1 followed by a number of zeros. Yeah? Now, we'll treat this as the first part of our solution. Now, let's say if we talk about the second part, we have again, let's say this exact similar table. It's going to be 32, 16. Again, if I could write 8, 4, 2, 1. Or rather, let's make this a little simpler, right? Let's say we write 16 in binary. This could be 16, 8, 4, 2, 1, right? This is 16 in binary. Now let's say I subtract 1 from the 16, right? This is 15. How do you think 15 would be written in binary? I'll leave that to you as a challenge, but I'll tell you for a fact that it becomes a completely mirror image of this one. So if it's 1 followed by a number of zeros, it becomes zeros followed by a number of ones. I challenge you, please try it. Now, again, if we talk about programming languages, we have the logical and comparison, which I assume most of you must be familiar with. But if I remove just this one ampersand from here, right? This is an operator that we don't tend to use too much, and that's why we are trying to, understand this today. This is basically what we call the bitwise operator. Please pardon my writing. It's too bad. Basically, it's called the bitwise operator. What it basically does, it takes two numbers, it takes two binaries, right? And it compares bit by bit. Like first bit of the first number, it compares the second bit of the second number with a logical AND, right? So let's say if I write 16 as a binary, it becomes 16, 8, 4, 2, 1. And if I write, let's say 15 in its binary, it becomes 0, 1, 1, 1, 1. So bitwise operator, what it will do, it will compare 0 and 1, a logical AND of 0 and 1, which is 0. Then for the next two bits, 0. For the next two bits, 0. The next two bits, once again 0. And for the last two bits, it's again 0. So that this is the pattern, and we are done, right? Basically says n, and this is n minus 1 in its binary, right? Bitwise AND of n and n minus 1 is always going to be 0. You can try this for any binary number possible, for any power of 2. In fact, you can try for any number that is not a power of 2. The bitwise AND of n and n minus 1 will not be 0. And if it's a power of 2, it will definitely be 0. Yeah, pretty neat. Yeah. So we'll use this, and that's our solution right there, right then. So let's say if I have const n, it says 20, right? I have a function with the check power of 2, which takes n as an argument, and just as a race condition, we can add, n should not be equal to 0 as well, yeah? Because we don't want any number that's not, let's say, negative, right? Let's say it's in points. So we are not going to treat that anyways, right? So n should not be equal to 0. At the same time, see what I did there? Just did. Okay, no, that's not so hard. Yeah. So what I did here, I said that n and the bitwise operator that we just saw of n minus 1, they should be equal to 0. And that solves our problem. Now let's say if I run this, I do console log check power of 2, I call it with n, which is 20 in this case. If I run this, it says false, right? Because 20 is not a power of 2. If I do, let's say, just 2, it tells me true. Let's take it a little further. Let's try 124. Is that a power? No. Let's try 128. It says true. Let's try 120. It says false, right? So, you see, just with the very basic idea, with a very basic information about computer sciences, we could write this function in just one line. We could solve this question in just one line. Yeah, and I think that's pretty neat because otherwise you'd be writing a while loop, you would be doing some modulus, you would be doing some divisions and stuff like that, which again, like I said, it's not an incorrect solution, but it's not an elegant solution at the same time, right? So I think this solves it. And again, I work as a JavaScript developer. I am writing this in JavaScript. If you work as, let's say, a C developer, you work in C++, or let's say you work with Java, you will definitely have to, type this a little more. We don't have any, defined set of types, data types basically in JavaScript. With C++, I think if the constraints are too big, you could go long, long, or something like that. But ultimately, you are just gonna write this, and that is gonna be a solution. Yeah, and I hope this was fun. I hope I was able to teach you guys something a little that you might not have come across before. And I'm gonna sign off with that one, and I'll see you in the next one. Thank you so much.